months, and I figured I would do a little video tutorial for it. So first of all, the unit circle is a special circle. It is centered at 0, 0. So this is like sitting on the coordinate plane where this is your x-axis and this is your y-axis. And it's a special circle because it has a unit radius. So the radius of this circle from here to here is 1 unit. So the radius of the circle is 1 unit, hence the unit circle. That means that this first point on the unit circle, this guy right here, is at over 1 and up 0. Okay? And then some other easy points to label because it's just on the xy axis. If I go over 0, 1, this point right here on the unit circle is over 0, up 1. And then I could go back 1 and up 0. So that point right there is at negative 1, 0. Or I could go over 0 and down 1. So this guy down here is over 0, down 1. So I know that this is a circle and there's a bunch of lines coming out of it, but really it's just sitting on your x and y axis. It's centered at 0, 0, and this is like, I could put this on a piece of graph paper basically. So after you get those 4 coordinates that are on the axes, the easy ones to get because they're all 1 unit away from 0, 0, the next easiest thing I think personally is to go around and label the degrees. So they're all based on special right triangles, so we're looking for our 30, 60, 90 or 45, 45, 90. So this first angle right here is 30 degrees. So I'm going to go ahead and label it, let's see, right here, 30 degrees. And then the next one is at 45 degrees. So this angle created with the x-axis, the positive x-axis, is 45 degrees. And the next one that you're going to hit is 60 degrees. Because we have a 30, 60, 90 triangle, a 45, 45, 90, and a 30, 60, 90 again. So the distance here, there's a pattern in the way that the distances jump. We jump 30 degrees and then 15, 15, and then we're going to jump up another 30 degrees because you guys can tell that this is a right angle. So that guy is 90 degrees. And then the pattern is going to continue. So we're going to jump another 30 degrees. 90 plus 30 is 120. And then we jump another 15 degrees because the distance between these two guys and these two guys is 15 degrees. So 20 plus 15, that puts us at 135. And then we're going to jump another 15 degrees. Let's see. 135 plus 15 is 150. And then we jump another 30 degrees and we get to 180. And 180 degrees should make sense because this is a straight line and we know that there's 180 degrees in a straight line. Then we keep going around the circle. We're going to jump another 30, so it puts us at 210 degrees. We're going to jump another 15, so that puts us at 225. When we jump another 15 degrees, we're at 240. And then when we jump 30, that puts us at 270. Okay. Jump 30 again, that puts us at 300. 15 more degrees puts us at 315. 15 more degrees after that puts us at 330. And another 30 degrees after that puts us at 360. So the beginning of the circle is 0 degrees, and then once you go all the way around, it's also 360 degrees. And then obviously you could keep going around in the circle and adding more, like we could go past 360 to 390, but for the unit circle we generally just label once around the circle. After you get your degrees labeled, the next thing that we're going to label are the radians. And radians you learned in last night's video tutorial, but just as a reminder, is a radius of the circle. So 1 radian equals 1 radius of our circle. That's why they're called radians. So if I were to take this distance here, this 1 unit distance radius, and I were to wrap it around my circle, so I were to trace around my circle the same distance along the arc, that would mark off 1 radian. And so a radian is just a unit of measurement, kind of like feet or inches. It's just a unit that we're measuring in. And for our purposes, since we want to go around the whole circle, I know the circumference of a circle is 2 pi r. And since my radius here is 1 unit, I'm going to get equals 2 pi times 1, which is just 2 pi. That means if I were to measure along the outside edge of my circle all the way around, when I went all the way around, I would get to 2 pi. Notice that 2 pi and 360 degrees land in the same place. So that means that 2 pi radians is equal to 360 degrees. This is kind of like in the same way that 1 foot is equal to 12 inches. So this is giving us a way to convert, basically, a conversion factor. Now if that's the case, I could divide both sides by 2, and I get that pi radians, I'm going to shorten it to rads, is equal to 180 degrees. So that means that I can come over to 180 degrees and label this pi. I'm going to start labeling these guys on the inside since I'm running around out of room on the outside. Okay. And then that would mean if I divide it by 2 again, that pi over 2 radians, or rads, is equal to 90 degrees. 90 degrees, my computer's freezing a little, there you go. And this guy is pi over 2. Well, we can do the same thing for 270, right? If I know that I have 270 degrees, I'm going to use a little stoichiometry from chemistry here, a little unit conversion. So the nicest one is using the fact that 1 pi radian is 180 degrees that I have written down over here. Now it's kind of like 1 foot is 12 inches. If I want the degrees to cancel out to convert to radians, I'm going to put 180 degrees on the bottom because I want the degrees to cancel. And 180 degrees is the same thing as pi radians. Now I cancel out the degree bubbles. Let's see, I can divide both of these by 10. And then what goes into 27 and 18? I think 9. So this is the same thing as 3 pi over 2 when I reduce that fraction. So here I get 3 pi over 2 radians at 270 degrees. So the degrees are measuring the angle measure, how big the angle is opened up. The radians, the 3 pi over 2, is measuring the distance along the outside edge of the circle, and they just happen to land in the same place. Okay. Now, we can keep going for this with the radians, so I'm going to switch colors. When I do this, I like to do my 45 degrees, 135, 225, and 315 first. So at 45 degrees, if I were to convert that to radians, I put the degrees on the bottom, so 180 degrees on bottom, and pi on top. And when I cancel out those degree bubbles, 45 goes into 180 4 times, so I get pi over 4. So that means that this guy is pi over 4 radians. And now I'm going to start counting by the same distance. If this distance along the unit circle is pi over 4 radians, that means this distance is also pi over 4 radians. So I can go 1 pi over 4, 2 pi over 4. Well, 2 pi over 4, 2 over 4 is the same thing as a half, so that reduces. So 1 pi over 4, 2 pi over 4, 3 pi over 4. That means this guy right here is 3 pi over 4 radians. And then 4 pi over 4 radians, well 4 over 4 is just pi. And then 5 pi over 4 radians. And then 6 pi over 4 would be the same as 3 over 2. And then I go the same distance and I'm at 7 pi over 4. And then 8 pi over 4, 8 over 4 is the same as 2, so it reduces to 2 pi. Okay. After you do your pi over 4s, those are the easy ones, so 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4, 6, 7, 8. Then you can do your 30 degrees, because each one of these spacings is 30 degrees, all the way around the circle. So if I do my 30 degrees, let's see, 30 degrees times pi over 180, I'm doing my conversions there. 30 goes into 180 6 times, so 30 degrees is the same as pi over 6. So these are going to be my pi over 6s. So here I get 1 pi over 6, that's my 30 degrees. And then I'm going to same distance. And this guy right here is going to be 2 pi over 6. Now 2 pi over 6 I can reduce. 2 goes into 6 3 times. So I would get pi over 3 here. And then 1 pi over 6, 2 pi over 6, 3 pi over 6 is the same thing as pi over 2. Here's 4 pi over 6. Now, 4 pi over 6 is going to reduce to 2 pi over 3. So this guy is a 2 pi over 3. Okay. And then I'm going to go the same amount. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6. So 150 degrees is the same thing as 5 pi over 6. 6 pi over 6, 7 pi over 6. 8 pi over 6 is going to reduce, because it's even, to 4 pi over 3. So this guy is 4 pi over 3. And then, let's see, 8 pi over 6, this guy is 9 pi over 6, but that reduces to 3 halves. This guy is 10 pi over 6, and let's see, 10 over 6 is going to reduce to 5 pi over 3. And then 11 pi over 6. And then 12 pi over 6 is the same thing as 2 pi. So by counting by pi over 6's, we can label all of our radians. And then counting by pi over 4's labels the ones that the pi over 6's don't catch. So it labels the ones in the middle. So the first thing you do is label the easy points on the axes. Then you go around and label your degrees, because that's the next easiest thing. Whether you decide to go by pi over 6's first or pi over 4's, it doesn't really matter, but you use that pattern of counting 1, 2, 3 as you're going around the circles to make it easier. And if you're ever unsure of like whether you got one right or not, you could always just convert from degrees to radians and see if those things match up. Now, the last thing you need to do, and I know this is a long video, you don't have to write this down, I just made it just as like a backup, is label the points on the unit circle. And so to do that, I'm actually going to grab a fresh unit circle because I'm running out of space here since I've been writing so big. So on your unit circle, because we're working with special right triangles, I think the easiest one to justify is the 45, 45, 90. So let me show you that as a special case. You don't have to do this work every time. I'm just going to show you where it comes from. So this hypotenuse, because it's a radius of a circle, is a 1 right there. This is 1 unit along. Okay. And if I didn't know what this was, x and x, but I knew that this was 45 degrees on this triangle, it's a special right triangle, then by the Pythagorean theorem, I know that x squared plus x squared equals 1. Well, that means that 2x squared equals 1. And if I divide both sides by 2, I get x squared equals a half. If I square root both sides, I get x equals, let's see, the square root of a half is 1 over root 2. And if I rationalize that, I get x equals root 2 over 2. So that means that this distance that I traveled over is root 2 over 2, and the distance that I went up is root 2 over 2. In terms of thinking about this now as like on a coordinate grid, you know, where this is 0, 0, and this is over 1, up 0, that means this point is over root 2 over 2, up root 2 over 2. Okay, so that's a special point on the unit circle. We have some other special points on the unit circle. This guy, let's see, I'll draw it in a different color, make it maybe a little bit easier to see. So this guy's purple. It has a radius of 1 also. Okay, because this guy right here is a 30, 60, 90 degree triangle, right here, you can tell that, and if you remember from geometry, there's some like special properties with 30, 60, 90s. If its hypotenuse is 1, then this short side here is a half, and the long side here, get this out of the way, is root 3 over 2. And so that means this place on the unit circle, this guy right here, I've gone over root 3 over 2, and I've gone up a half. So this special coordinate is over root 3 over 2, and up a half. And then the 30, 60, 90 degree triangle for the 60 degrees, if I change colors and draw that in, right here, okay, is the same triangle for our 30, 60, 90, it's just flipped. So now that I've gone over a half and up root 3 over 2. Over a half and up root 3 over 2. Okay. The last thing you would need to do on your unit circle, these points, these 3 guys, now all can be transferred using symmetry so that you don't have to kind of do so much work to figure it out each time. So I would take these 3 points that I just got, and I would put them on my unit circle. Now you don't have to derive them. I think the easiest one to put down is root 2 over 2. And then you know it's going to be a half and root 3 over 2, so this one has gone over more than it's gone up, so I know it's my over root 3 over 2, up a half. And this guy right here has gone over less and up more, so it's over a half and up root 3 over 2. Okay. Once you get those, you can start transferring them using symmetry. So notice that if I draw a dashed line across from here, that this point is exactly the same height from the xy axis and distance, from the y-axis. It's the same triangle here, it's just flipped, right? So this one's gone back root 3 over 2 and up a half. So I go back root 3 over 2, up a half. And then if I go down here, I can use the same symmetry. I have the same triangle here, where I've gone now back root 3 over 2 and down a half. So it's back root 3 over 2 and down 1/2. And then if I follow it across to this guy right here, this one is the same triangle. I've gone over root 3 over 2 and down a half. Notice the negatives are popping in when I go back or down. And then my root 2 over 2's in this guy, if I trace it over, I've gone back root 3 over, or back root 2 over 2, up root 2 over 2. So this one's negative. And then if I trace it down, I've gone back root 2 over 2, down root 2 over 2. And then if I trace it over, I've gone forward root 2 over 2, down root 2 over 2. And then I can trace it back up to sort of make a rectangle almost. And then last but not least, I've got my other guy up here. So it's gone back 1/2, up root 3 over 2. And then if I trace it down, it's gone back a half, down root 3 over 2. I trace it over, and I've gone forward a half, down root 3 over 2, and then it matches back up with this guy. Okay. So your unit circle quiz for Friday is going to need to have the degrees labeled, you're going to need to have the radians labeled, and you'll need to have these key points labeled, including the ones on the axis, like over 1, up 0, over 0, up 1, back 1, up 0, down, or sorry, over 0, down 1. So you're going to have points, radians, and degrees all labeled on one unit circle. I know it sounds like a lot, but if you use the patterns and if you use the symmetry, it'll make it a little bit easier to follow out. Thanks, guys.